time always runs the same way. It never goes backwards. And we're aware of time because we notice that things happen one after another.
Time always moves in a single direction, never reversing or pausing. We recognize its passage because events unfold sequentially, one after another. Time remains one of the great enigmas of the universe, perceived as a constant force that ceaselessly propels us forward. But what if this perception isn't entirely accurate? What if, under certain conditions, time could actually flow backward? In an astonishing breakthrough, scientists may have observed negative time for the first time in history. This revelation challenges our long-held understanding of time's irreversibility and could have far-reaching consequences for physics, technology, and even our perception of free will. For centuries, the nature of time has captivated the minds of physicists and philosophers alike. From the musings of ancient Greek thinkers to Albert Einstein's groundbreaking theories of relativity, our comprehension of time has undergone profound evolution. Despite these advancements, time has remained persistently unidirectional, until now. Researchers at the forefront of quantum physics have made an extraordinary discovery. They have recorded instances where time appears to move in reverse. This defies everything we thought we knew about the fundamental nature of reality and opens the door to questions that were once confined to the realm of science fiction. But how is such a phenomenon possible? How can time reverse itself, and what does this mean for our everyday lives? To uncover the answers, we must venture into the perplexing and often counterintuitive domain of quantum mechanics. In classical physics, time is regarded as a one-way street, a notion deeply intertwined with the second law of thermodynamics. This law dictates that entropy, a measure of disorder in a system, always increases. It explains why shattered glass does not spontaneously reassemble or why cream, once poured into coffee, never separates back into its original form. Our everyday experiences reinforce the belief that time only flows forward. However, within the microscopic realm of quantum mechanics, this principle is not as absolute as it seems. Quantum mechanics governs the behavior of subatomic particles, where the rules of physics defy conventional logic. At this scale, particles can exist in multiple states simultaneously, teleport across vast distances instantaneously, and, as recent discoveries suggest, potentially experience time moving in reverse. Scientists achieved this groundbreaking observation by manipulating quantum systems in precisely controlled environments. Using ultra-cold atoms and carefully calibrated laser pulses, they created conditions that led quantum particles to exhibit behaviors contradicting the expected forward progression of time. A crucial mechanism underlying this discovery is the principle of quantum superposition, which states that a particle can exist in multiple states at once until it is observed or measured. Researchers found that, under certain conditions, these particles could be induced into a state where their wave functions evolved in a manner that mirrored the past rather than progressing into the future. This reversal of the expected sequence of events is what scientists are referring to as negative time. To illustrate this in simpler terms, imagine a game of billiards where you strike a cue ball, but instead of rolling forward, it retraces its path back to its starting point. This is essentially what was observed at the quantum level, though in an even stranger and more counterintuitive fashion. One particularly striking aspect of this discovery is its potential connection to time reversal symmetry. In theoretical physics, time reversal symmetry suggests that the fundamental laws of physics should function identically whether time moves forward or backward. While classical mechanics has never demonstrated this phenomenon in practical reality, quantum mechanics now appears to provide evidence that, under specific conditions, time may indeed be reversible. This discovery leads to profound questions. If time can be reversed at the quantum level, could this principle ever apply to macroscopic systems? Is it possible to develop technology that manipulates time itself? While such ideas remain purely theoretical at this stage, the mere observation of negative time marks a crucial step toward understanding what might be possible. One of the most exciting potential applications of this discovery lies in the realm of computing. Quantum computing already defies traditional logic, and the newfound ability to manipulate time within quantum systems could revolutionize information processing. If time can be controlled in quantum environments, it could pave the way for advancements in error correction, computational speed, and even entirely new methods of data processing that are currently beyond human imagination. Beyond technology, this discovery also challenges our fundamental understanding of causality, the relationship between cause and effect. In our daily experiences, causes always precede their effects. You flip a switch, and then the light turns on. But what if, in certain quantum systems, effects could precede their causes? While this notion may sound like something out of a science fiction novel, researchers are now grappling with the possibility that negative time could upend our foundational assumptions about the nature of reality. Beyond physics and computing, the implications of negative time stretch into the philosophical and existential realms. If time is not strictly linear, does that mean our past, present, and future are not as rigidly defined as we assume? Could this discovery lead to new interpretations of free will and determinism? If the future is not set in stone, might we one day discover ways to influence events that were once believed to be inevitable? Of course, this does not mean that time machines are on the horizon. The effects observed so far are limited to incredibly small scales, and translating these principles into real-world applications remains an enormous challenge. However, history has shown that quantum mechanics has led to transformative technologies such as semiconductors, lasers, and MRI machines, innovations that were once considered inconceivable. The discovery of negative time could eventually pave the way for future breakthroughs that are currently beyond our comprehension. As research continues, scientists will strive to refine their experiments, test new theories, and push the boundaries of what negative time can reveal about the universe. Though this discovery is still in its infancy, one thing is certain: the observation of negative time represents a paradigm shift in science. It forces us to reconsider everything we thought we knew about reality and opens a door to possibilities that once seemed purely hypothetical. While we may not yet fully grasp the implications of this finding, it provides us with a tantalizing glimpse into the profound mysteries of the cosmos. This discovery serves as a powerful reminder that our grasp of reality remains incomplete and that each breakthrough has the potential to reshape the fundamental laws we once believed to be absolute. As we push the boundaries of physics further, who can say what other astonishing revelations lie ahead? The universe is an expansive, enigmatic realm filled with countless mysteries, and the observation of negative time is yet another example of how much we have yet to uncover. The very nature of time itself may be far more complex and extraordinary than we have ever imagined. For centuries, humans have been captivated by the concept of time, striving to measure, analyze, and comprehend its essence. From primitive sundials to state-of-the-art atomic clocks, our attempts to master time have been relentless. But what if everything we thought we understood about time was fundamentally flawed? What if time is not solely a forward-moving force but can also move in reverse? While this may sound like something out of a science fiction novel, recent experiments suggest that negative time, or time flowing backward, may be more than just a theoretical possibility. Scientists have now witnessed a phenomenon that was once deemed impossible: a system behaving as though time were running in reverse. If this discovery is validated, it could fundamentally alter our understanding of physics, reshape our perception of reality, and even influence our theories about the fate of the universe. But what does it truly mean to observe negative time? Could this be a step toward unlocking the secrets of time travel? Might it offer an explanation for some of the strangest quantum phenomena we've ever encountered? And perhaps most intriguingly, how might this revelation impact our perception of the past, present, and future? Let's delve deeper into the mechanics of time and explore the implications of this astonishing discovery. We experience time as an unyielding forward progression. We are born, we grow older, and eventually, we pass away. A shattered glass never reassembles itself, nor does a cup of coffee that has gone cold suddenly reheat without external influence. This perception of time's unidirectional flow is known as the arrow of time, a fundamental concept in physics that explains why time appears to move in only one direction. The arrow of time is closely linked to entropy, a measure of disorder within a system. According to the second law of thermodynamics, the entropy of a closed system will always increase over time. This explains why objects tend to break rather than mend themselves and why heat flows from a hot object to a colder one rather than vice versa. Entropy provides a strong rationale for why time moves forward, but what if there were circumstances in which entropy could decrease instead of increase? Would that imply that time could, in fact, reverse its course? For decades, physicists have debated this intriguing possibility. And now, for the first time in history, experiments have yielded direct evidence suggesting that negative time is not merely a theoretical construct but a real phenomenon. So, how exactly did scientists observe negative time? The answer lies in the peculiar realm of quantum mechanics, the branch of physics that governs the behavior of particles at the smallest possible scales. Researchers at a leading quantum computing laboratory designed an experiment using a quantum computer, specifically IBM's quantum processor. Quantum computers function using qubits, which are the quantum equivalent of classical computer bits. Unlike standard bits, which exist strictly as either a 0 or a 1, qubits can exist in both states simultaneously due to a phenomenon known as superposition. In their experiment, the scientists created a simple quantum system and observed how it evolved over time. Normally, quantum systems tend to spread out and become increasingly disordered, following the principles of entropy, similar to an egg breaking or ice melting. However, something remarkable occurred. By applying a carefully designed algorithm, the researchers introduced a special operation to the system. Under normal circumstances, the system would continue evolving toward greater disorder, but in this case, the quantum system defied expectations. It reversed its state, effectively rewinding to an earlier configuration. It was as if time had started moving backward. This was not a mere computer simulation or a theoretical projection, it was a real, observable effect. The quantum system physically behaved as though time had reversed, defying everything we assume about the natural flow of time. This experiment suggests that, under specific quantum conditions, time may not be strictly linear, it can also move in reverse. This revelation raises some of the most mind-boggling questions imaginable. Does this mean that time travel is no longer confined to the realm of fantasy? Could this principle eventually lead to the development of a functioning time machine? And if time can move backward at the quantum level, could it also do so in larger, more complex systems, perhaps even in our everyday reality? The idea of time reversing is not entirely new. Some interpretations of quantum mechanics have long hinted at this possibility. One particularly notable example is the Feynman-Stueckelberg interpretation, which proposes that antimatter particles could essentially be viewed as ordinary particles moving backward in time. According to this interpretation, when a particle and its antiparticle collide and annihilate one another, it can be understood as a single particle traveling forward in time, then backward, and then forward again. This concept aligns with the nature of quantum superposition, in which particles can exist in multiple states simultaneously, meaning they might not be bound to the rigid timeline that governs classical objects. Some researchers suggest that, at extremely small scales, time itself may be bidirectional, capable of flowing both forward and backward simultaneously. The latest experiment may have finally provided tangible evidence supporting this theory, demonstrating that, under the right conditions, time reversal is indeed possible at a quantum level. If time can move backward, does this open the door to paradoxes? One of the most famous paradoxes in time travel theory is the grandfather paradox. In this scenario, a person travels back in time and prevents their own grandfather from meeting their grandmother, thereby preventing their own birth. But if they were never born, how could they have traveled back in time to alter the past in the first place? Paradoxes like these have long made time travel seem implausible. However, the latest findings suggest that negative time in quantum systems does not necessarily allow for such contradictions. Instead, it hints at a deeper, more intricate way of understanding time, one where past and future influence each other in ways we have yet to fully comprehend. The implications of negative time extend beyond physics and into some of the biggest mysteries in the cosmos. Could this phenomenon be connected to dark matter and dark energy, the unseen forces shaping the universe? If time is not strictly linear, could it help explain why the universe is expanding at an accelerating rate? While there are no definitive answers yet, one thing is clear: the observation of negative time challenges the very foundation of our understanding of reality. It suggests that the universe is far more complex than we ever imagined and that the true nature of time may still be one of the greatest mysteries left to unravel. As researchers continue to refine their experiments and probe the limits of what is possible, we may soon uncover even more mind-bending truths about time, reality, and the fundamental workings of the cosmos. One of the most thrilling possibilities arising from the concept of negative time is its potential to unravel some of the greatest enigmas in modern physics, namely, dark matter and dark energy. Dark matter is an invisible substance that constitutes approximately 85% of the universe's total mass. Despite decades of extensive research, scientists remain uncertain about its true nature. Even more perplexing is dark energy, an unknown force responsible for accelerating the universe's expansion rather than allowing it to slow down, as classical physics would suggest. Some physicists have theorized that dark matter and dark energy may be connected to hidden dimensions of time, regions where time operates differently from how we perceive it in our everyday experience. If negative time can exist within quantum systems, could it also manifest on a grand, cosmic scale? Is it possible that entire galaxies are moving backward in time relative to us? If this hypothesis were confirmed, it would revolutionize our entire understanding of the universe, challenging everything we thought we knew about space, time, and the fundamental forces that govern reality. The notion of manipulating time has captivated human imagination for centuries, serving as a staple of myths, legends, and science fiction. Until recently, the idea of bending or reversing time seemed to belong purely to the realm of fantasy. However, this groundbreaking experiment suggests that under the right conditions, we may be able to influence the flow of time at a quantum level. Though this discovery is still in its infancy, the potential applications of time manipulation are truly staggering. Quantum computers could one day harness time-reversing processes to correct computational errors. By exploiting the ability to move quantum states backward, these machines could become exponentially more powerful and precise, revolutionizing data processing and encryption. Could we eventually use quantum time control to repair cellular damage? If so, this technology could have groundbreaking implications for treating diseases and slowing down the aging process. The ability to reverse cellular decay or heal damaged tissue at a fundamental level could redefine modern medicine and extend human lifespans. If scientists can determine how to scale this effect beyond the quantum realm, could we one day build machines capable of slowing down, stopping, or even reversing time? While such an achievement remains purely speculative, the fact that we have observed negative time in action suggests that the future may hold far more extraordinary possibilities than we ever imagined. As research continues, we may soon find ourselves on the precipice of a new era, one where time itself is no longer an unchangeable force but a controllable element of reality. Thank you for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more amazing content. We'll see you in the next video.